These are the frequently asked questions for pre-calculus, and this is for section 1-4, day 1. Number 9 says f of x equals x squared and g of x equals 1 over x are shown below in the viewing window from 0 to 5 and 0 to 5. Sketch the graph of the sum f plus g of x by adding the y coordinates directly from the graphs. Then graph the sum on your calculator and see how close you came. So here's what they're saying. What we really want to do is think, all right, if we have f of x, and g of x, and we've added those two pieces together, where would this go? And what that means to us is we're really taking the outputs of these two equations and we're adding them together. So this window was just from 0 to 5. We could do this. We could say, all right, if I put a 0 in here, I'm going to get 0. If I put a 0 in here, that doesn't exist. So we see how the blue graph is starting down here. The other one isn't existing. Now, if we go to putting in something, like a half. So putting the same value in for both of those. 1/2 squared will be 1/4. And 1 divided by 1/2 will actually be 2, so that will be 2 1/4. So at 1/2 we need to go to 2 1/4. Now visually, what we're doing is we are taking the height of y at this point, and we are adding the height of the blue graph. We're putting those two things together by adding those outputs. So if it bothers you, drives you nuts, that they want you to do this visually, you could do it numerically. Use the formulas and figure out where everything's going to go. So to kind of make a little table and put together, this is your answer for f of x, this is your answer for g of x, and then together you'd have f plus g in this column. So we had 1/4 and we had 2, so that gave us 2 1/4. And you might add a little x column over here and say that was for 1/2, And then go to 1, plug a 1 in. 1 squared is going to give you 1. 1 over 1 is 1. So at 1, we should be graphing 2. Right here. And then we put in a 3. Actually, you should probably just put in a 2, otherwise this is going to get pretty high pretty fast. If we plug a 2 in, 2 squared is 4, and 1 over 2 is 1/2. So that will be 4 1/2. So at 2, we're at 1, 2, 3, 4 1/2. And here's what we notice. Visually, it really is a matter of just taking the red graph and adding the blue graph. And that's what we get. Now, on the calculator, what they wanted you to do was graph the sum. And you can either do that by actually doing the algebra, but a faster way would be to just put those two functions in and go into variables, y variables, number 1, pick number 1, hit enter. Let's put a plus in there. We want to add that to the other one. So plus variables, y variables, functions, number 2. Pardon me. And then we'll just hit graph. So there's the blue graph. There comes the red graph. And the next color we see will be our sum. And so this window that I have on my graphing calculator is not the same as what we saw in the book. So let's change this and make it 0 to 5 and 0 to 5 like it was in the book, and just take a visual look at this, how close that is to the blue graph that I have over below number 9. And the book shows it's not too bad. It's pretty close to what we see when we get that. So now the next thing I'm going to do is shut down the graphing calculator so that this doesn't impede my screencast here. So give me a second. Well, from there, you had a couple of problems, and we had talked about in class that it was, the domain that was kind of bugging you. It wasn't necessarily the math. Number 16, we know we're supposed to find f of g of x and g of f of x. And part of that composition piece is talking about the domain. So for number 16, we want to find that domain of f of x. And we look at f of x and realize there aren't any numbers, no restrictions on what we can square. That's not an issue. But for g of x, we know we can't use 1. If we use 1, we will have a 0 in our denominator. So we'll go from negative infinity up to 1. We'll have to hop over it on the number line and go out to infinity. So then the next step is to actually do the composition. So when I have f of g of x, I'm right away thinking about the fact that g is going to be the input. So already I know my domain is going to be restricted, thinking ahead to the very end of the problem when we talk about domain. So to get f of g of x, I have f of x equals x squared minus 1. And I have my little g of x, which equals 1 over x minus 1. And my job is to replace the x value in f with the entire function from g of x. So that will become f of g of x. And that will be 1 over x minus 1, the quantity squared, minus 1. So f of g of x comes out to 1, because 1 squared is 1. We can distribute this power of 2, by the way, because we can distribute whenever it's pure multiplication or division inside the problem. So the 1 is squared. And then on the bottom we would have the quantity x minus 1 squared minus 1. Now that's what we're going to write for our answer. And if you're thinking, shouldn't we get a common denominator and simplify that? The answer is, would you really be simplifying it? You know, we would have to use the least common denominator of x minus 1 squared. That's not going to be simplifying it if we actually take this further. And then the next step would be, if we have, we're using the domain of f of g. So what do we do here about the domain? Well, we check to see did anything new come up. And as we look at our final answer here, we see that 1 is still an issue. 1 was an issue before. We knew 1 was going to be an issue, but nothing new has come up. So the domain of f of g is negative infinity to 1, hop over 1, and go to infinity. Now we're not done, because they did say we need to do this both ways. So now we're going to work on g of f of x. So for that, I need my g of x, which is 1 over x minus 1. And wherever I see an x, I am going to replace it with x squared minus 1. So this is going to go right there. And that will give me 1 over x squared minus 1 minus 1, which is 1 over x squared minus 2. Now that changes things. You know, originally our domain of f was all reals. That was our input here. That was all reals. But now, if we have 1 over x squared minus 2 for g of f of x, we have to think, when is x squared minus 2? When is that going to be 0? Because that would be a problem. Well, we'd add 2 to both sides, take the square root, and have to remember that it's going to be the positive and negative square root of 2. That would be an issue for that problem. So now we need to figure out, you know, what numbers can we use? We know that negative square root of 2 is out and positive square root of 2 is out. Well, remember from our domain of f, our input, everything else was okay. I mean, we had all real numbers. So now it's just a matter of remembering, hey, as you're moving from the number line left to right, you have to resist the urge to use that square root of 2. So the domain of g of f of x is going to be negative infinity, and then we're going to get to negative square root of 2, and we're going to have to stop and hop over it, and then negative square root of 2 on the other side, making that hop. We'll continue that until we get to positive square root of 2, and then again we have to hop over that and continue on forever. So that's going to be quite the domain that we see there, just because we really needed to leave two numbers out. You know, that's what we had to do. So now what? Well, now I have to erase all this wonderful math so I can go back and take a look with you at number 18. So let me turn this off and get that stuff off of here. Number 18, we have f of x as 1 over x minus 1. We have g of x as the square root of x. So, domain of f, we can't use 1. You know, we just encountered that in number 16. So, we're going to have to make sure that we include everything else, but that we're hopping over that 1 on the number line. And then the domain of g, we have to start at 0 and only use positive numbers for our square root. So this is going to be pretty similar to what we saw in 18, but obviously we have some differences because now we're working with square root. So we want f of g of x, and what I'm thinking right now is, you know, about my domain and how my domain was restricted for the domain of g. So I already have a restricted domain. I'm just looking for anything else new that's going to come up. So for f of g of x, I need to take this and put it right there. So that's going to be 1 over the square root of x minus 1. So now I already know that I had a restricted domain, and I'm looking at the square root of x minus 1 and thinking, okay, well, you know, it's not so much the 0 that's a problem anymore. It's whatever is going to make that square root of x minus 1 equals 0 in my denominator. So we would go ahead and add 1 to both sides, square both sides, and get x equals 1. So if we put a 1 into that function, we are going to have trouble with number 18. So here's what had happened so far. We had said, all right, well, 0 and above is what we have to use. And so now we know we can't use a 1. So as we do the domain of f of g, we again think number line here. We can go 0 to 1, but we have to make a hop to go back over, because we know that we cannot use that 1 in our denominator, because that would give us a 0. Now, g of f of x, let me erase a little bit here. G of f of x, this in here. The square root of 1 over x minus 1. Now, this one, again, I think unless you're going to do this with the graphing calculator and graph it, you would probably want to rationalize the denominator to see what's going on. Because here we would have 1 over the square root of x minus 1. But you can also kind of see here what's going to happen too, just like in the last one. If you think about it, you know, we have the square root of x minus 1 that has to equal 0. So either way, the book had encouraged us to do it graphically, but we can't have that be equal to 0. With f of x, our restrictions were we just couldn't use a 1, because that would make our denominator equal to 0. But now this is going to be a new issue. So we're going to have to make sure that we don't use 1. I already know that from the input, f of x, but there might be something else. So we square both sides, and then we add 1. And of course that makes sense, because if we put a 1 into this function, 1 minus 1 is going to give us 0. So we're just constantly checking as we go through there. And of course, sometimes you can just look at it and say, well, 1 minus 1 is going to give us 0, you know, and 1 was already out as far as the domain goes. So for g of f of x, you realize, well, it's still going to be the same domain, except now we can't do negatives because of the square root. So we're not going to be putting 0 in there. That would give us the square root of -1. So our domain of g of f of x is going to have to make all of that happen, and that means we're going to have to start at that 1. But we can't use exactly 1. We can use 1.1. We can use 1.0001. So anything to the right side of it, and then anything going on the right side of the graph will keep that positive. So those are the explanations for the domain issues in those problems.